Hello, welcome to the 7-4 notes on special right triangles. Now, if you're wondering where 7-3 is, it's gone. We don't do it anymore, so we just go 7-1, 7-2, 7-4. This is the last section of the school year, woo, before the semester ends. So let's get right to it. First, we're going to do a little bit of reviewing with radicals. So the first problem asked me to simplify the following. Square root of 5 times square root of 5 is equal to the square root of 25. Square root of 25 is just a weird way to write the number 5 because 5 times 5 is 25. Therefore, the square root of 25 is 5. Remember, square rooting and squaring are inverses of each other. They undo each other. Done. All right, next one. Square root of 2 times square root of 3 is equal to the square root of 6. There are no perfect square factors in there, so that would be my answer. All right, number 3, we have two different ways we could do this. We could do square root of 24 times 18. So we would get, let me just double check that, 432. Or I think the easier way to do it is to simplify each of these first. So do each radical individually and then worry about multiplying them together. So square root of 24 I know is the square root of 4, there's that perfect square, times the square root of 6. Square root of 18, the perfect square that's in there, is the square root of 9 times the square root of 2. So now this would equal, the first one is 2 square roots of 6 times the second one is 3 square roots of 2. Okay, so the rules of multiplying radicals do get confusing for kids. Next year it's going to be even more complicated when you have square roots, cube roots, things like that. And by next year I mean in Algebra 2. But for now, when you have radicals, you could take and you're multiplying them. You can multiply the numbers on the outside together. So the 2 times 3 is 6 times the square root of, and now you can multiply the numbers on the inside together, you get 12. Notice square root of 12 can be simplified further. So there's a perfect square of 4 in there. So I could write that as 6 times the square root of 4 times the square root of 3. Square root of 4 is a weird way to write the number 2. So I have 6 times 2 is 12, and then square roots of 3. All right, so next one, square root of 7 squared. Like I said earlier, square roots and squares cancel each other out. It's like dividing and multiplying, adding and subtracting. Those two undo each other, so when you have the square of a square root, you just release the number underneath, which by the way is called a radicand, but that would just equal 7. Or if you want, because it's squared, you write it twice. Square root of 7 times the square root of 7 is equal to the square root of 49, which hopefully you do recognize is equal to 7. Next one, 2 square roots of 3, and that's being squared. So you could either give this 2 to both things inside, so you would have 2 squared times the square root of 3 squared, and then do it that way, or write it out twice. And I think this is the preferred way for most kids. They like to write it twice and then multiply 2 times 2 is 4, and then times the square root of 3 times 3, which is 9. So 4 times 3 is 12. And that's our answer there. I should probably box all these. All right, number 6, I want you to try on your own. So pause the video and I'll get back to you and we'll see if our answers match. Okay, for that one, you should have gotten that the answer is 45. If not, make sure you ask your teacher in class tomorrow. All right, next part, rationalizing the denominator. We're going to simplify if possible. So just off to the side here, well, to rationalize the denominator means you cannot have a radical in the denominator. So when you end up with a radical in the denominator, you have to get rid of it. So now the way we're going to do that is to get rid of the square root of 2. I have to multiply it by square root of 2 because I set up on top that if you multiply a radical with itself, you will release that number. So this denominator would be just 2. But I can't just go and multiply something on the denominator. I can't just like, okay, I'm just going to multiply by square root of 2. No, I have to do it to the top as well. And so now, if you notice, this square root of 2 over square root of 2, that's just 1. So I've completely changed the way this fraction looks, but I haven't changed who it is. So rationalizing the denominator is like plastic surgery of numbers. You multiply top and bottom, so it totally looks different, but it's still the same thing deep down. And just so you know, in front of this radical 2 that's in the numerator, there's a 1 in front, so there's nothing I could do to simplify with the denominator. All right, number 10. get rid of that square root of 6 from the denominator. I have to multiply top and bottom by square root of 6 over square root of 6, because square root of 6 over square root of 6 is just 1, and as long as I multiply by 1, I am not changing the value. So 3 square roots of 6 is in the numerator, because 3 times the square root of 6 is 3 square roots of 6, over square root of 6 times square root of 6, that's the square root of 36. Square root of 36 is just 6. The reason we multiply by whatever that radical is to release that number from the denominator. So now something happens here that didn't happen in the previous example. These two numbers, I could simplify them. These two in the previous example, I could not. And the reason I can't in number 9 is because one of the numbers is underneath the square root sign and the other one isn't. If that happens, you can't simplify those numbers. They have nothing to do with each other. They don't simplify, nothing. Here, though, notice that the 3 and 6 in number 10, they're both outside of what I call the jail. I call the square root sign the jail. And I could simplify. 3 goes into 6 2 times. That leaves me with square root of 6 over 2. And just like in example 9, I can't simplify those. We don't mix numbers inside a jail with numbers outside. They don't combine. This doesn't equal square root of 3. So please don't make that mistake that you're going to think that it equals the square root of 3. Okay, last one here. Square root of 2 over the square root of 11. Multiply top and bottom by square root of 11 over square root of 11. Square root of 2 over the square root of 11 is the square root of 22. This would be over the square root of 121. Square root of 121 is just 1. So again, remember, just quick lesson. Square root of 7 times square root of 7, 7. Square root of 5 times square root of 5, 5. Square root of 10.3 times the square root of 10.3 is 7. Just kidding, 10.3. Likewise, with simplifying or rationalizing the denominator, there's also a shortcut you could use. So for example, if I had 7 divided by the square root of 3, what ends up happening is this number comes up top to join whatever's up there, so it becomes 7 square roots of 3 over, and then you just release that number, so it's 7 square roots of 3 over 3. Again, 7 and 3 have nothing in common, so I cannot simplify them. So again, if I had 5 divided by the square root of 6, this would equal 5, the radical comes up top, becomes 5 square roots of 6 over just a 6. If I had 10 divided by the square root of 2, this would equal 10 square roots of 2 over 2. Can I reduce these? Does 10 and 2, do they have anything in common? They sure do. That would be 5 square roots of 2. And if you don't understand that little shortcut for rationalizing, hopefully maybe in time it'll get easier for you. If not, it didn't take me that long to do number 9, 10, and 11 by multiplying top and bottom by the same radical. So just do it that way. All right, so all of that was in preparation for our new idea in this chapter, which is special right triangles. Now, they are special because with these triangles, you only need to know one side of the triangle, and you could find the other two sides. Whereas in section 7.1, when we did Pythagorean theorem, you needed to know two sides of a triangle to find the third one. In 45, 45, 90, all you need to know is one side. So here, it tells us in a 45, 45, 90 that, so that's our special new triangle, it tells us that the hypotenuse is square root of 2 times as long as each leg. So I do like to write the legs as cursive lowercase l. So it's L and L because the legs of an isosceles, if these are 45, that means these legs have to be congruent. Okay, so X and X, so we could mark these. So you could be given that triangle's square root of 45 degrees, or you could be given that the legs are congruent, or you could be given that the angles are marked congruent. So I always write, okay, everything's in terms of the leg. That's the big head honcho here. And the leg times the square root of 2, that's how you would get the hypotenuse of this triangle. Okay, so that's the important idea. So this is L, this is L, this is L root 2. So if that's L, if 3 is equal to L, then I know this is also 3 because those are both L. And then the hypotenuse up here, this missing length, is L times the square root of 2. So example 2 here, we also have a 45, 45, 90 triangle. We are given this leg is 6, so this is L root 2. So this missing side here, the other leg, is also 6. And the hypotenuse, this guy, would equal 6 times, whoops, sorry about that. This would be 6 times the square root of 2, because the hypotenuse is equal to the leg times the square root of 2. And if you don't believe me, do the Pythagorean theorem and simplify, and you will see that that is indeed 6 square roots of 2. Right, here we have L, this equals L root 2. So I'm going to take this little equation, and I'm going to solve for the variable, which is L. So I'm going to divide both sides by the square root of 2. And now I have L is equal to 4 divided by the square root of 2, which I have to rationalize. So, shortcut way, 4. The radical 2 comes up top and joins whatever was in the numerator. And in the denominator, I release the 2. Can I simplify anything here? Well, only outside numbers with outside numbers. 4 and 2 do have something in common, so it's 2 square roots of 2. And that's what each of these legs would equal. Right here, L, and this is already L root 2. I think it looks, on my copy, it looks a little bit cut off here, that 5 root 2. But in any case, I'm going to take that equation, 5 square roots of 2 equals L square roots of 2. I want to get L by itself, so I divide both sides by square root of 2. These two cancel because they're both inside of jail, so I could simplify those, and 5 is equal to L. If you're confused by this, that's totally normal. It happens. This is probably the toughest section of Chapter 7, in my opinion, in my experience with students. We are not learning anything new after this, so we have a bunch of days to review and perfect this, and as long as you try, students usually do very well on this section. All right, this brings us to our last of the the special right triangles, and that's a 30, 60, 90. So in a 30, 60, 90, you have to be given that one of the angles is 30 or one of the angles is 60 or both. Okay, so again, I like to call this L root 3. This side I call L, and this side I call 2L. So everything here is in terms of the leg. And sorry, that's not correct. I meant to say the short leg, because this triangle doesn't have legs that are the same length because the angles aren't the same. Remember from chapter 4, and even from this chapter, the smallest angle is always across from the shortest side. So the short leg here is L. The long leg, which is the one across from the 60-degree angle, this guy over here, the long leg is the short leg. So I like to write it out in words sometimes. That helps students. Short leg times the square root of 3. And then the hypotenuse, which is across from the 90-degree angle, the hypotenuse is going to equal 2 times the short leg. So in a 30, 60, 90, because everything is in terms of the short leg, there's a relationship between the long leg and the short leg. There's a relationship between the hypotenuse and the short leg. If you're given the short leg, that's the best thing you could be given. It's the easiest thing to figure out for the rest of them. The hypotenuse and the long leg don't have a direct relationship, so that makes it a little bit more difficult. However, if you're given the hypotenuse, you could very quickly find the short leg and then be done with it. So let's label this. This is the short leg, so it's L. The long leg is L root 3. The hypotenuse is 2 times L. So if I go in and plug in, that's my short leg. It's 2. So then this guy is going to be 2 root 3. How do I get that? Because it's L, whatever L is. In this case, it's 2. And then I multiply by the square root of 3. The hypotenuse is going to be 2 times 2, because the short leg is 2, so that equals 4. Okay, for number 2, you are given the hypotenuse. So the hypotenuse we could label is 2L. Short leg is across from the 30-degree angle. That's L. Long leg is L root 3. So take this and solve for L. If 10 equals 2L, because as long as I have L, I can figure all the other sides out, it's going to equal 5. So now I go back in and I plug that into the equation. So 5, and this one would be 5 root 3. All right, number 6, I'm given the long leg, and I know I'm given the long leg because it's across from the biggest angle other than 90, but the 60-degree angle. So this is L root 3, hypotenuse is 2L, short leg is L. Let's take this and let's solve it for L. So 6 equals L times the square root of 3. I divide both sides by the square root of 3, and I see that I have 6 divided by square root of 3 is what L equals. Let's rationalize it. If you want to multiply top and bottom by square root of 3 over square root of 3, that's fine. Or shortcut 6, the radical comes up top and the 3 gets released. These two can be simplified, so it's 2 square roots of 3, and that's what L is. All right, so that means this short leg, which is just L, this guy is 2 root 3. And if I do 2 times 2 root 3, this is why we reviewed radicals in the beginning, it's 4 times the square root of 3. Right, this one I can't see what that says, so let's just cross out number 4. Okay, here we're given the hypotenuse. The hypotenuse is 2 times the short leg. It's 2L. L is across from 30, that's the short leg. This one's L root 3. Also, that kind of reminds me, students a lot of times, especially later, is like, okay, I know one of them has a square root of 3, one of them has a square root of 2. I have a hard time remembering each one, because like I said, this section is not easy. If you're confused, that's pretty typical. I always say these two guys, see how they both have a 3? That's how I always tell kids to remember which one has a radical 3. It's the one that has a triangle that has a 3 within its angles. All right, so let's go ahead. Let's solve this for L. Sorry, I'm still in my Highlander mode. Okay, so 2L equals 7. L is going to equal 7 halves, aka 3.5. So then, if that's what L is, this side is 3.5. This side is 3.5 root 3. Okay, last one here before we start mixing them up. This is the long leg, it's L root 3. This is 2L, and this leg is called L. So let's go solve this equation over here. Kind of running out of room. Sorry, everyone. All right, so this equals L root 3. It's the long leg. Divide both sides by the square root of 3. So right now, I have 3 root 2 over the square root of 3. This one I'm going to actually rationalize by showing, because there's a radical on top and bottom. I would multiply top and bottom by the square root of 3. This gives me 3 square roots of 6 over the square root of 9, which is 3. Now, don't forget, you could only simplify numbers that are either both inside a radical or both outside. 3 and 3 simplify, so I get L is equal to the square root of 6. So 2 times the square root of 6 is literally 2 times the square root of 6. It's not the square root of 12. It's nothing fancy like that. And then here we get L, which is the square root of 6. So, in short, 30, 60, 90 triangles, the best thing you could be given is L, the short leg, because then everything else is in terms of it. The worst thing you could be given is the long leg, because notice anytime I was given the long leg as a number, it took me a lot of work. I had to divide by radical 3 to find the short leg. Okay, so let's check your understanding. So the first example here, we have a 45, 45, 90 triangle. So if you don't remember, flip back to the other page, but the legs we always label as L and L. They're congruent, and the hypotenuse is L square roots of 2. So we get this side is 8. This side then has to be 8, because we get 8 equals L, and then the hypotenuse is 8 square roots of 2. That is always the case. If you don't believe me, watch what happens when I do Pythagorean theorem. 8 squared plus 8 squared, if I call these legs, they're congruent, and I'm going to call the hypotenuse x. Pythagorean theorem would be 64 plus 64 equals x squared. I get 128 equals x squared. When I square root both sides, I have to simplify square root of 128. That's the square root of 64 times the square root of 2. That's x. That's what x equals. So 8 square roots of 2 equals x. And that's going to be the true for any isosceles right triangle. If the legs are 3, it'd be 9 plus 9. Square root of 18 is 3 root 2, and so on. Okay, number 2 over here, we have a 30, 60, 90. I know that because the angles are marked. Don't start marking angles that aren't there because there are going to be Pythagorean theorem problems, and kids then get confused between the two and they think every triangle has to be a 30, 60, 90 or 45, 45, 90. If that were true, then they wouldn't be special because every triangle would be a special right triangle and then they'd just be triangles. All right, so here we go. Let's mark these. This is L. This is L root 3. This is 2 times L. Let's take this one because I have a value, I have an equation. 4 equals 2L, so I get L is equal to 2. I take that number now, I know X is going to equal 2 root 3. I know Y is going to equal whatever I got for L, which is 2. All right, last page here. So 45, 45, 90 could be expressed to you in a few different ways. This one I know is a 45, 45, 90 because these two legs are congruent. If they are congruent, then the two angles have to be congruent as well because it's an isosceles, and those would each be 45. All right, so the legs are always L. The hypotenuse is L root 2. Let's take this one because I have a number there, so I could solve for L. L root 2 equals 2 root 2. Divide by the square root of 2 on each side. Those cancel out, the square root of 2's I mean. So the length of the leg is just 2. So X is 2. Whoops. Since X is each of the legs. Right, number 4, we have a 30, 60, 90. Let's call this L. Let's call this L root 3. And this looks awfully familiar because I think I literally just did this problem as number 2 on the other page. So cross that guy out. All right, over here, we have this one. So short leg is across from the 30. It's always L. L root 3 is the long leg. The hypotenuse is 2 times the short leg, so 2 times L. So here, boom, L is given to me, so Y is going to equal 6 square roots of 3. X is going to equal 12. All right, number 6. Let's keep going. X is the short leg. 9 is the short leg times the square root of 3. Y is 2 times L. Which of these gives me an equation where I only have one variable? This guy down here. So 9 is going to equal L times the square root of 3. Divide both sides by square root of 3. And now I can't reduce these. I have to rationalize, right, if I clean this up. So it'd be 9 square roots of 3 over 3. These two can be reduced. So L equals 3 times the square root of 3. All right, plug that in for X. So X is going to equal what L is, so 3 square roots of 3. Y equals 2 times L, so 2 times 3 square roots of 3 gives me 6 square roots of 3 for Y. All right, last one here. I know that's isosceles because those two legs are congruent, even though it wasn't marked for me. Those two legs are congruent, so that's L. That's L, and the hypotenuse in a 45, 45, 90 is L root 2. So if I want to find the missing side, this is the only side that's missing. It's going to be 3 root 2, because that's what L is, times the square root of 2, because that's what's already, or that's what I have to multiply by, right? It's L, just 3 square roots of 2. I plug that in, and then times the square root of 2. This is going to equal 3 times the square root of 4. Square root of 4 is a weird way to write the number 2, so that's just 6. All right, last problem over here. Find the exact, meaning I am not going to press anything on my calculator. I'm not going to estimate anything. I'm not going to get a decimal, but I'm finding the exact area of an equilateral triangle with a side length of 10. Whoa, that's pretty gross. Okay, so equilateral means all angles are the same, all sides are the same. It's all congruent. Each side is 10. The area of a triangle is 1/2 its base times its height. So far I know 1/2, the base is 10. I don't know the height. I'm going to have to go find it. So height, we just talked about altitudes and all that stuff. I'm going to drop it down. Okay, and what I've done is I've created a 30, 60, 90 triangle. I'm going to redraw it here so we have it again. This is 10 because that was 10. This is my 60-degree angle because this was my 60-degree angle. And when I dropped it, if this entire base was 10, my new base here is 5. So in a special right triangle, this is L, this is 2L, so that matches, right? 2 times 5, and the long leg is L root 3. The long leg here is my altitude, so it's 5 root 3. Right, so that's what I'm going to put in my blank space here, 5 square roots of 3. So anytime there's fractions and there's not fractions, many times kids struggle. Like, how do you multiply it? So, I don't know what to do. It's 1 times 10 times 5 is 50. And then the square root of 3 just tags along because you can't combine it, but it is multiplied. We say that's 50 times the square root of 3. In the denominator, we got 2 times 1 times 1. That gives me 2. Can I simplify these? Well, look at that. Those two numbers have something in common. So the final area here would be 25 square roots of 3, and then my units are centimeters, and area is always squared. Okay, so that's it. I know it's not easy. It's kind of complicated. It's confusing. A lot of times when the teacher's doing it, it's easier to follow, and then when you have to try it on your own, it's difficult. So if you struggle, make sure you ask in class tomorrow, and I'm sure your teachers will go over it with you. And like I said, nothing new anymore, just a quiz coming up in a couple of days where we'll just be reviewing and practicing all this stuff. All right, thank you so much for watching, and enjoy your day or evening. Bye.